Section 6 of Chapter 6, the fundamental theorem of algebra. Alright, it's not that exciting, but it sure sounds good. And let's see, let's get my laser pointer here. There we go. But the fundamental theorem of algebra, this is a super important concept, but it's really not that complex. In fact, we've already seen it in the last couple days. So let's take a look. In fact, all of this stuff, there's actually not anything really new that we're going to see today that we haven't already seen the past few days. So, learning targets. We can use the fundamental theorem of algebra and its corollary to write a polynomial equation of least degree with given roots. We'll see that on the next slide when we see what the fundamental theorem of algebra is and its corollary, and I'll also explain what is a corollary at that point as well. And then we can identify all roots of a polynomial equation. It's pretty much just like we were doing last time. We were finding all the roots of a polynomial equation. The difference is, last time it was all the real roots. This is just all roots. So we'll have some complex roots in there. So what is this fundamental theorem of algebra? The fundamental theorem of algebra says that any polynomial with a degree of at least 1 has at least one zero. Woo! It has at least one zero. Not really that important. We have a corollary. Now, a corollary is a second theorem that goes right along with the first. It relates to the first, and it is proved really, really easily with the first. So we prove the first one, and then this one would prove really quickly right after that. When I was in college, I had a professor who was visiting from England, and so he pronounced things like aluminium. And corollary, he pronounced corollary, so it was amusing to all of us. I'm sure you're not amused at the moment. Anyway, the corollary was every polynomial function of at least degree n is greater than or equal to 1 has exactly n zeros, including multiplicities. So that means we have the same number of degrees as zeros. When we have x to the fourth, we're going to have 4 zeros. When we have x cubed, we're going to have 3 zeros. If we have x to the seventh, we will have 7 zeros. We've seen that. We've already been counting the zeros that we've had. That's all this says. It tells us how many zeros to expect. So let's find all of our roots. These will use the same techniques that we've been using for the past few days. We have x cubed minus 3x squared plus 4x minus 12 equals 0. How could we factor this? Well, step 1, factor out what they have in common. It's nothing there. Step 2, look at the number of terms. 4 terms, factor by grouping. Can we factor this one by grouping? It looks like we might be able to, because here we have 1 minus 3. If we get rid of a 4 here, 1 minus 3. So let's work on factoring by grouping. So x squared, x minus 3, 4, x minus 3. And then they both have x minus 3 in common. So we can take that out, get x squared minus x squared plus 4 equals 0, which means that either x minus 3 equals 0 or x squared plus 4 equals 0. If x minus 3 equals 0, x equals 3. If x squared plus 4 equals 0, we can subtract the 4 to get x squared equals negative 4, and then square root. When we square root, we'll have an I because it's negative, and remember we'll also have a plus or minus. So a plus or minus the square root of negative 4, which is plus or minus 2i. And so notice we have 1 and then another 2 of them, so 2, 3. We have cubed, so we have 3 roots for cubed. If you're trying to do this just with a graphing calculator, you'd see the x equals 3. There's absolutely no way you're going to get the imaginary roots from that. So it's still important to be factoring and stuff like that. Graphing calculator is a great tool that can help us, but it will not take the place of the algebra. Let's look at another one. X to the fourth minus 5x cubed plus 3x squared plus x equals 0. Step 1, factor out what they have in common. Hey, they all have x's in common. So we can factor out the x's. And now we're looking, It does not look like it's going to be factorable by grouping, so we can use the rational root theorem. We could graph it to see what are our possible roots, but when we look at our constant, 1, we look at our leading coefficient, 1, our possible roots are plus or minus 1. Not all that many to choose from. So, let's try one. Oop, plus or minus 1, 1. It's possible roots plus or minus 1. So let's try with 1. We can bring down the 1, and then add, multiply, add, multiply, add, multiply, add, and we get 0. Look at that. 1 is a root. And we're left with a quadratic, x squared minus 4x minus 1. We can deal with a quadratic. Notice I didn't lose my other roots. We had 1 as a root, so the factor is x minus 1, and we still have this x in front that came from the x in front up there. So we have x equals 0, x equals 1, and whatever we might get from this. Now looking at this, we could try and factor it, but off the top of my head, I'm not coming up with any numbers that are going to multiply to give me -1 and add to give me -4. So, quadratic formula. We can always use the quadratic formula with a quadratic. That's why we get it down to a quadratic, because we have other methods at that point. So, quadratic, so x equals 0, x equals 1, or quadratic formula, plug in my b minus 4 times a times c. A is 1, so the 1s aren't going to change anything there. And then we can square the -4 to get 16, and multiply to get plus 4. 16 plus 4 is 20. 20 is 4 times 5, so that 4 is a 2 and a 2. One of them can make it to the outside. One of them doesn't make it out. So we end up with 4 plus or minus 2 root 5 over 2. And then we can simplify. 4 over 2 is 2. And the 2 over 2 is just 1, so we'd end up with 2 plus or minus root 5. So this is 2 roots. We have 2 plus root 5 and 2 minus root 5. Then we also have 0 and 1 to give us 4 roots. So we wanted 4 roots. We found 4 roots. That's all the fundamental theorem of algebra is talking about. It's like, hey, we need to find 4 roots. Yay, now we're just doing the exact same thing we were doing before. Except, back here we had plus or minus -4. You know, last time, we got there and I'm like, so wait, stop, hold your horses. Well, go ahead, let go of your horses. Let them run free all over this assignment. Let's look at another one. X to the 4th plus x squared minus 12 equals 0. Alright, well, we have 3 terms. See, can we do this as a quadratic? Well, 2 and 4, yeah, it's possible. 2 numbers that will multiply to give us -12, add to give us 1, like perhaps 4 and -3. X squared plus 4, x squared minus 3 equals 0. Which means either x squared plus 4 equals 0, or x squared minus 3 equals 0. X squared plus 4 equals 0, x squared equals -4, x squared minus 3 equals, square root both sides, we get plus or minus 2i. X squared minus 3 equals 0, so x squared equals 3. Square root both sides, x equals plus or minus root 3. How many roots were we looking for? We were looking for 4, and we found 2 of them here, and 2 of them here. And so that's 4 roots. And notice here, we wouldn't get any nice roots if we were to graph this. And so you'd find your plus or minus root 3. That's going to give you an approximation, and it's not going to get you your imaginary roots. So again, graphing is a skill that can help, but not take the place of. So, speaking of which, let's see how can the graphing help. Let's take this one. X to the 4th minus 3x cubed plus 5x squared minus 27x minus 36 equals 0. That's a big one. There's that general quartic equation that we were seeing yesterday in the history people are having trouble solving. Well, it's not going to fit with our factoring techniques, so we have to use rational root theorem, P's and Q's. We have P's are factors of 36. Well, there are a lot of factors of 36. Plus or minus 1, 2, 3, 4, 6, 9, 12, 18, and 36 are all factors of 36. Thankfully, Q is just 1, so we don't have to worry about that. So now, how do we use the calculator to help? Let's graph this. X to the 4th minus 3x cubed plus 5x squared minus 27x minus 36. Graph it and see what we get. We're going to get a graph that looks kind of like this. Like, alright, well, I don't even need to do the trace thing or the calculate thing. Looking at this, it looks like it hits -1. Is that one of my possible roots? Yes, it is. I'm going to guess -1. It also looks like it hits 4. Hey, that's another one of my possible roots. Let's guess 4 as well. Once we have those two, that'll take it down to a quadratic, and we can do something else with it. So, let's try with -1. We have the 1, we can bring it down, multiply, add, multiply, add, multiply, add, multiply, add. Hey, look at that. -1 worked. What a great guess. Now that we have this piece, we need to do it with 4. So, bring it down, multiply, add, multiply, add, multiply, add. And look at that. 4 worked as well. How super. So, and now we have a quadratic. X squared plus 9 equals 0. We can deal with x squared plus 9 equals 0. That's not going to be a problem. But what this was is it allowed us to make these two good guesses instead of having to go through a whole bunch of trial and error there. That's what the graphing calculators can help us with. So if we were to write down our factors here, we have x plus 1 and x minus 4, and then x squared plus 9 equals 0. And notice each time we lost one, like I didn't need to worry about this 0 when we did the second one. So x plus 1 could equal 0, which means x equals -1, which we actually get from right up here. And then same thing, x could equal 4, or x squared plus 9 could equal 0, which means x squared could equal 9, which means x could equal plus or minus 3i. And we were looking for 4 roots. We have 1, 2, 3, 4. So there we go. So that would be finding all roots with the graphing calculator. The only thing different here from before is that we have this I, and we found it the exact same way we were finding it with quadratics. So take a couple minutes and try a couple. We have x to the 4th plus 4x cubed minus 3x squared minus 14x minus 8 equals 0. And x to the 4th plus 14x squared plus 45 equals 0. Go ahead, pause the video, see if you can figure out the answers. You should have 4 answers in each of them. And then go ahead and push play again when you're ready. Did you find all 4? Well, let's see. So this one, we're going to have to use rational root theorem. Factors of 8 will be plus or minus 1, 2, 4, and 8. I'm going to graph it because I'm going to like seeing the graph of this. So, alright, so it looks like -4. That's one of our possibilities. -1 and 2 are going to be possibilities here. -1 and 2 are also there. When I look at the graph, I see this -1. See how it comes down, it hits it, and then turns around? That tells me that -1 is a double root. It'll work twice. These guys just kind of go through it. Those will probably just work once. If it's a triple root, it'll also go through it, but it'll kind of flatten itself out. Like it won't look like a straight line through it. So let's try a number. -1 looks like the easiest one to try. So let's try that one. Bring it down. Multiply, add, multiply, add, multiply, add, multiply, add. Look at that. -1 works. How's your guys' synthetic division coming along? Are you getting quicker at it yet? Alright, well, now we have this. I'd try -1 again. you may have used different numbers. That's okay. We'll come out with the same answer. So I'm using -1 again, synthetic division. And look, -1 worked again because it was a double root. And now, since, hey, we see 4, we see 2, we could use synthetic division for those as well. But once I get mine to a quadratic, I like just dealing with the quadratic. X squared plus 2x minus 8, we can factor that. X plus 4 times x minus 2, which means x equals 1, x equals 1, or -1, -1, and then -4, and +2. And -1 is a double root, just like we saw. So we have 1, 2, 3, 4, x to the 4th. All right, how about the other one? This one can factor like a quadratic. X squared plus 9, x squared plus 5, which means x squared plus 9 equals 0, x squared plus 5 equals 0. So either x squared equals -9 or x squared equals -5. Square root, x equals plus or minus 3i. And square root, x equals plus or minus I root 5. Those are the 4. Now if you tried to graph this, it does not have a single real root. It will never touch the x-axis. The graph isn't going to help you at all. You need to be able to factor this. But we factor, we get our 4 roots. So that's the big part of this. And it's the same as it was. The other piece, writing polynomials from roots. We saw this in the last one, although it wasn't actually on the homework yet. But if we have roots, let's say x equals 2, 1, and 2/3, well, what factor would give us x equals 2? It would be x minus 2. So x minus 2 is a factor. What factor would give us 1? X minus 1. And then 2/3, we'd have x equals 2/3. We could multiply by 3 to get 3x equals 2. Subtract 2, so 3x minus 2 equals 0. And then equals 0 to make the equation. There we go. That's a cubic polynomial from these roots. You could multiply it out. Don't. Just leave it factored. Well, that's when they're all nice rational numbers. How about if we're trying to write a polynomial with roots like 2 minus I, and root 3, and 2? We saw last time that if we have an irrational number, its conjugate is also a root. So root 3 is a root, that means negative root 3 is a root. We have what's called the complex root theorem as well, which says exactly the same thing about complex numbers. If 2 minus I is a root, then so is its conjugate, 2 plus I. So we can start this out with, well, let's start with 2, x minus 2. And then we have x minus 2 minus I. We also have x minus 2 plus I. You might be thinking, shouldn't that 2 minus I be in parentheses? Technically, yes, but it actually doesn't matter. Because you distribute the negative anyway, you're going to end up with 2 minus I and 2 plus I. So you get both of them. Technically, this is x minus 2 minus I, and this one over here is x minus 2 plus I. Does not matter. But we get those two. We'll also have x minus root 3, and if we have x minus root 3, we have x plus root 3 equals 0. You could leave it like this if you want to. I know some people really feel the need to be multiplying their conjugates together. The x minus root 3 and x plus root 3, it just doesn't sit well with them. They like to multiply to get x squared minus 3. And then multiplying these two together as well to get x squared minus 4x plus 5. Just because people don't like seeing roots and i's in their factors, that's fine. I would not multiply it any further than this. And so that was section 6. That's dealing with complex numbers and knowing how many roots we're going to be looking for at all in the first place. So don't forget to comment, and I'll see you in class for a group activity.